Chapter 4.5 is exponential and logarithmic equations. We've already solved some exponential equations and we've already solved some logarithmic equations. Recall when we were solving exponential equations, we made the bases the same. So that's the first thing we're going to try. Don't forget to try to make the bases the same. But if you cannot make the bases the same, for example, this problem right here, I can't write 1/2 or 5 or 2 or 5 with the same base. Then I'm going to use logarithms because remember, logarithms and exponentials are inverses. They undo each other. Okay? So I could square both sides of this if I want to, right? Or raise it to the 4th power or take the square root of both sides as long as you do the same thing to both sides. Well, a logarithm's an exponent. A logarithm's an exponent. So I can take the log of both sides as long as I do the same thing to both sides. Now that I have done the same thing to both sides, taking the log of both sides, I have a property of logarithms that lets me bring this exponent out to the front. And now it's a simple linear equation. Remember, these values are numbers. Those are numerical values. I just don't know exactly what value they are. So I'm going to divide both sides by the natural log of 1/2. So that I have x equals. Now I'm also going to use my property to simplify this. Remember, if I have two arguments being divided, I can change that with two logarithms being subtracted. And the reason I would want to do that is because this now symbols. Remember, what's the exponent you put on e to get 1? Oh, that's 0. So that really simplifies my problem some. And now, if you're on your homework, you're going to plug that in your calculator and get a numerical answer. If you're on a test, you're just going to box it, and there's your answer. All right, let's try that again. So I noticed that it's an exponential problem. My variable is up in the exponent. I cannot make the bases the same, so I've got to try to use logarithms. But before I can take the log of both sides, I have to have this exponential value isolated. Just like any other time you're using an exponent. Remember our radicals, which are exponents, you had to isolate the radical. So same thing here. Divide by 3. Again, trying to isolate. Excuse me. Once I have my exponential isolated, then I'm going to take the log of both sides. Log with base 10 or natural log. It doesn't matter. Either one of those I can plug in the calculator for a numerical answer if necessary. So just take the log of both sides. Then the property allows me to bring that exponent out to the front. And after that, it's a linear equation. The only variable I have is an x to the 1st power. Okay, so let's distribute and get rid of those parentheses so that I can get that x all by itself. I got to break it out of those parentheses. Now remember, all of this, anything that doesn't have a variable in it, an x in it, is a numerical number. So I'm going to move that over. Let's see, I'm going to have a space issue when I get to that problem anyhow. All right, So that's gone. And now I just have something being multiplied by my x. So divide both sides by natural log of 2. And you've isolated your x. You have x equals natural log of 33 plus 2 times the natural log of 2 all over the natural log of 2. And again, if I needed a numerical answer, I can now just plug that in my calculator. Okay, have an exponential problem. All right, variables up in the exponent. These have the same base, so I can use my property of exponents, which says if I'm multiplying two exponential numbers with the same base, I simply add the exponents. So 3x minus 7 plus negative 2x is x minus 7 equals 4. Now, once I get the exponential isolated, I'm going to take the log of both sides. But I notice in this one, my base is 10. That means I want to take the log with base 10 of both sides. I do not want to use my old standard fallback natural log. And if my exponential had a base of e, I would not use log with base 10. Because notice what happens. Okay, I have the property that lets me bring my exponent out to the front. But log of 10, if the bases are the same, the exponents are the same. That's just 1. So now this problem completely simplified to just x minus 7 equals log 4. And all I have to do is add 7 to both sides to get my x all by itself. All right. So if I have a base 10 or e, that will dictate which logarithmic base I'll use. But otherwise, it doesn't really matter. Whoops. Okay, this problem, I'm going to start over here just so I'll have room, right? I notice I cannot make the bases the same. This exponential is already isolated, so I'm just going to take the log of both sides. Natural log of 3 to the x minus 4 equals natural log of 7 to the 2x plus 5. Now my properties of logarithms allow me to bring that exponent down. And once again, it's just a simple linear equation. I just got to remember that these are numerical values. They're not variables. So get rid of parentheses, just like always. Distribute that number through. And distribute this number through. Whoops. Okay, now I want my variables on the same side, and here's my variables. This is just a number, that's a number. So I'm going to subtract this from both sides to get my variables on one side and add this to both sides. Okay, so I have, so that's gone, x natural log of 3 minus 2x natural log of 7. equals, because that's plus 0, equals 0 plus 5 natural log of 7 plus 4 natural log of 3. Okay, so only numbers over here, no x's over here. I got a couple x's over here, and I can't add them together because they're different kinds of terms. So another way I can get one x out of there is to factor it. Remember, anytime you're unsure of what to do, look for something to factor. Oh yeah, I can factor an x out of these two terms, right? Leaving me one x. Okay, so now I've got an x times some stuff, so all I have to do is divide both sides by natural log of 3 minus 2 times natural log of 7 to give me x equals 5 times natural log of 7 plus 4 times natural log of 3 all over natural log of 3 minus 2 natural log of 7. Okay, now if I needed to enter that in my calculator for a numerical answer, don't forget I would have to have parentheses around the numerator and the denominator to get the correct answer. So, if you have an exponential equation, try to make the basis the same. But if you cannot make the basis the same, isolate the exponential and take the log of both sides. Now, if the equation already has a logarithm in it, then we're going to try to get rid of the logarithm. And we already know all I have to do is change it to its exponential form. So 5 to the third power, 5 cubed, equals 8 minus 3x. 5 cubed is 125 equals 8 minus 3x. Subtract 8. 125 minus 8 is 117 equals negative 3x, and divide by negative 3. Just like we've already done in a previous section. So what's that? Negative 39. Now, recall, with logarithms, you must check your answer because your argument cannot be 0 or negative. Your argument must be positive. It's okay for your x to be negative, but when I plug it into the argument, just like with a radical, right? Because it's exponential. 8 minus 3 times negative 39. I don't really care what it is. It's a positive number, so I'm satisfied with that. But don't forget to check your answers on those logarithms. Okay. Our problem with this is that I can't change it to exponential form. It's got logarithms in it, but I can't change it to exponential form until there's one logarithm. So I'm going to use my properties to condense this down into one logarithm. Because there's a minus here, I'm going to write my arguments as quotients. Oh, log 10, look, log 10, that could be a 1. We're going to talk about that more. I'm going to leave it like this for right now. We're going to look at 2 or 3 things just for us to think about. Whichever way you feel comfortable is fine. Okay, always goes without saying I'm going to try to simplify any rational expression. So I'm wondering if there are 2 numbers that multiply to give negative 39 and multiply to give 10. Yeah, 13 and negative 3, right? And that's great because that certainly lets that simplify. So I have log of x plus 13 equals log 10. Now, I got 2 or 3 choices here. Okay, one thing I could do is continue to move. I need one logarithm, right? This problem had one logarithm, and when I have one logarithm, I can change it to its exponential form. So I could continue to put all my logs on one side. Right, and then combine these using my properties. So I'd have, whoops. And then I can change it to exponential form. The base, when it's not written as a 10, 10 to the 0 equals it. So there's one option. So I could do that. Or, let's go way back up here. Or, we could recognize, like we mentioned earlier, from right at the start, that, oh, log with base 10 of 10 is 1. And then right here, I'm already at that point where I could say, okay, 10 to the 1 equals x plus 13 because I have one logarithm, right? Or I could also recognize that, hey, log of this is equal to the log of that. The only way that can happen is if these arguments are equal. The log of something equals the log of something, then this has to equal that. That's the only way that can happen. Just like with our exponents, if the bases are the same, the exponents have to be the same. So x plus 13 equals 10. I'm going to get the same answer anyway. Now, don't forget I have to check this. Uh-oh. And I see right away that if I plug it in this argument, so don't forget to check those solutions in your argument. If it makes any argument not positive, it's not a possible solution. Okay, so this is identical to this problem. I've got to combine, and most of them are identical. Combine into one logarithm. So I have 5 plus 4x over 3 plus x. And at this point, again, I recognize, hey, if the natural log of this is the exact same thing as the natural log of that, then this has to equal that. And I've got a simple rational equation that doesn't involve logarithms that I can now solve. So to solve this equation, let's multiply both sides by 3 plus x to get rid of that fraction. And we have 5 plus 4x equals 9 plus 3x. So 5 plus x equals 9. And x equals 4. And let's go up and check it. 5 plus a positive number is positive. 3 plus 4 is positive. Works. Awesome. You've done it. You've completed every section. Let me know if you have questions.